So one feature of computational irreducibility is that within any computationally irreducible system, there are eventually an infinite number of pockets of reducibility. In other words, to know everything about what will happen is an irreducible question. But there will always be particular things that you can say. And actually, when we come to talk about sort of fundamental physics and so on, one of the things that happens there is sort of the underlying dynamics of the universe is deeply computationally irreducible. But our existence sort of is within certain pockets of reducibility. It is if we just took the sort of the kind of underlying rules of physics and we just looked at those and we didn't we would probably say, how can we predict anything about what's going to happen in the world? Well, what's happening is that we are kind of keying into certain pockets of reducibility. And that's how the world comes to be a place that seems somewhat predictable to us. So a good example of this is you have a gas and it's got a bunch of molecules bouncing around, and the details of how those molecules bounce around is full of computational irreducibility. But when we observe the gas, the main thing that we concentrate on is the very large-scale aggregated motion of those molecules. And turns out that certain features of that are computationally reducible, so we can write down simple formulas for pressure and volume and temperature and so on of gases. And those work because we've kind of keyed into this pocket of computational reducibility, and we've not had our noses rubbed, so to speak, in the computational irreducibility of the detailed motions of all these molecules. So the thing is, there are things in science where we're going to find these pockets of reducibility where we are going to be able to say things, and then there are going to be things where there is irreducibility where we're not going to be able to say things. And sometimes the things that we really care about saying will turn out to be things for which there is computational reducibility, and we can write down a formula and sort of jump ahead. Sometimes the things we really care about will not be things that are computationally reducible, and there really won't be a choice but to just sort of follow each step and see what happens. And the fact that there is that branch where it might be the case that science can't just say we're going to be able to predict what's going to happen is something that I think people are sort of, well, the vast mass of people, I would say, have not yet come to terms with, because people are still kind of in that 1600s type model of what science is, which was very surprising at that time, but 300 years later seems obvious to people that there's just a formula for things, and that's what science is about.